Alright, hello everyone. So today we're taking a look at the 5.10 notes. This is going to introduce us to a system of inequalities. So after we first did equations, we then did linear inequalities where we used dotted or solid lines shaded above below. Well, then we did systems of equations, 2 equations at a time. So today we do systems of inequalities, 2 inequalities at a time. To start, we're going to begin with a review of a linear inequality. So remember, to graph a linear inequality, we use the same features we do for linear equations at first, and that would be a y-intercept, b is -3. We also have a slope, m is 4. You can make that like 4 over 1, and remember, rise and run to go up 4, right 1. Now the y-intercept, -3, gives us a starting point right there. The slope tells us to move up 4, 1, 2, 3, 4, and right 1. We can do that a few more times. 1, 2, 3, 4, right 1. Remember, you could even go double negative and go down and left. So I can go down 4, 1, 2, 3, 4, left 1. Now, with a linear equation, we would just connect the dots, draw a line, we're done. But with a linear inequality, we're going to remember this was a greater than symbol. That tells us 2 things. First, we're going to use a dotted line. That the line itself is not actually part of the answer because it's not equal, which is where the line is. And to show that it's greater than, we're going to shade above. So I'm first going to connect these points with a dotted line, just kind of throw some dots in between there. And then to shade above, remember, you pick any point on the line, you move up above it, and you see which side you're on. And I see we're over here. So that's a quick review of a linear inequality. Well, for a system of inequalities, we want to find all the points that make both inequalities true. So if in an inequality all my answers are in this shaded area, any point over here, not the points on the line, that's why it was dotted, and not the points down here, but anything in the shaded region, those are the solutions. Well, with a system, we're going to find the solutions that make both inequalities true. It would be impossible to list all the points, so we graph and shade instead. We need to graph each inequality separately. So it's basically like doing 2 different problems just on the same graph as each other. But then once we do these 2 problems on the same graph, we look for where their shaded sections overlap. So we're going to have one shaded region like this, but then right on the same graph, we're going to have another shaded region. And we want to see, do those shaded regions overlap where both of them are true at the same time. So let's go ahead and take a look at our example down here, number 1. You'll notice I crossed out number 2. There's a mistake with the problem. Some of it takes place off the graph, so we're going to skip that one. We'll be good with just our one example for this. So I'm going to take equation 1 right up here. And for equation 1, I'm going to make a few notes. Like the y-intercept, b is -2. Like the slope, m is -1. Which is -1 over 1, which goes down 1, right 1. And then I'm even going to note that this greater than symbol is telling me to do dotted and above. So I'm going to go ahead and do all that and graph inequality 1 now. So starting with a y-intercept of -2, then going down 1, right 1, down 1, right 1. Remember, I could reverse that, go up 1, left 1, up 1, left 1. Do that a few times. Then connecting them with a dotted line. And shading above, which again, put your pen on any random point, move above the line, and you see which side you're on. Now when I do this, I'm going to draw all kind of shaded lines that are perpendicular to the inequality that I drew. Since this isn't the only one being graphed now, I want to kind of be conscious of looking at one shaded region, then looking at another, and then seeing where they cross each other. So for inequality 2, I'm going to identify all the same things. Y-intercept is 6. The slope is 3. That's 3 over 1. Now that's going to go up and right, or -3 over -1 can go down and left. And then we have a less than or equal to symbol here. Sorry, let me get some stuff out of the way. It's a less than or equal to symbol. And that's going to be solid and below. So let's go ahead and do that. That's a y-intercept of 6. There's my y-intercept. I can't go up 3 over 1, but I can go down 1, 2, 3, left 1, and down 1, 2, 3, left 1, and maybe one more time. 1, 2, 3, left 1. This one gets a solid line. And it goes below. So pick any point here, go down, and you can see we're on this part down here. Now I'm going to do these again with segments that go kind of perpendicular to the line that I drew. And so once I do this, you can see the two lines basically break the graph up into 4 sections. There's a section over here where nothing is shaded in, neither of the inequalities are true. There's a section right down here where only the second inequality was true. There's a section up top right here where only the first inequality was true, but it's this section to the right where I see the first inequality was true, the second inequality was true. It's where it overlaps. So these are the answers. And so is this solid line, only this part here, because down here the line might be true, but the shading for this inequality isn't. So what you end up with is a boundary where this is solid, this one is dotted, and then darken in where all the answers are. So now that I know this is the answer zone, I'm going to really emphasize that and make it stand out from the rest of the problem and show there that's where all my answers are. On this line going this way, not on the dotted line, but anything in here. So again, just graph the two separately, look for where they overlap, darken in the overlapped part. We're going to, again, skip number 2. The rest of these notes now are kind of flipping this around, and now we write the system. If we look at a graph that's already done, can we figure out which inequalities made it? So we're going to identify the slope, m, and the y-intercept, b. And we're going to do that for both of the lines shown. We're going to need slope and intercepts for both of them. We're also going to have to determine whether the shaded area is above. And we know if it's above, that's telling us to use one of the greater than symbols, either greater than or equal to, or is it below, in which case that's telling us to use one of the less than symbols, less than or equal to. And finally, determine whether the line is solid. Of course, if it's solid, that's telling us it is equal, and that means we choose one of the or equal to's. Or is the line dotted, in which case it is not equal, so we choose one of the inequalities that don't have an equal sign. So let's go ahead and check this out. First, just to help keep things clear, I'm going to call that one, the dotted one, is line number 1. We have inequality number 1. And I'm going to call this one, the solid one, is inequality number 2. Now, technically, it doesn't matter. If you did that the opposite, it wouldn't make a difference. We just want to come up with our 2 inequalities. The order does not matter. So for inequality number 1, well, what do I want to do here? I want to identify a slope and a y-intercept. So inequality number 1 has a slope of 1. That's a y-intercept of 1. Got that backwards. That's y-intercept of 1. Now I want to find a slope. That means picking another point on the line and showing that maybe I went down to right 3. And that would be a slope of negative 2/3. That went down to right 3. I also see that the line was dotted, and that the shading, you'll notice there is no shading in any of these areas because they only darkened in the part that worked for both. So when I look at how this part relates to that dotted line, I see it's below it. It's underneath the dotted line. And if it's dotted and below, then I'm going to choose a less than symbol. So I'm ready to write inequality number 1. It must have been y is less than, and then I go ahead and use the slope, negative 2/3 x, and the y-intercept, plus 1. There's the y-intercept, there's the slope, and the less than symbol tells me it's a dotted line that was shaded below. So let's do all that again for inequality number 2. Inequality number 2 has a y-intercept of negative 3 it has a slope, looks like I can use that same point again, of up to right 3. And that's a slope of 2/3. I also see that this line is solid and also shaded below. All that shading is underneath that solid line. So that tells me to use a less than or equal to symbol. That's y less than or equal to the slope 2/3 x and the y-intercept -3. I'm going to go ahead and do one more and then we'll wrap this up. So again, you kind of have to pick randomly which is which. I'm going to call this one inequality 1. I'm going to call that one inequality 2. So for inequality 1, I'm looking for a y-intercept. Looks like I got it right there at -2. I'm looking for a slope, and I have to find another point on the line. Looks like I might want to choose that one right there. And that went down 1, 2, 3, 4, right 1. That's a slope of -4. That line looks to be solid. And when I look at where it's shaded, all the shading, pick this point for instance, is above that point, not below it where it's empty, but above all this stuff over here. So that's greater than or equal to. Now I can write inequality 1 is y greater than or equal to -4x minus 2. And one more time for inequality number 2. This time I'm using this line here that I identified as inequality number 2. I'm using its y-intercept, which is 3. For its slope, I can use the point that's right next to it and just go up 1, right 1. The slope is 1, or 1/1. That line is also solid. This line, however, look at that point right there. The shading is below it, not above it. So solid below. That's less than or equal to. So that's y less than or equal to the slope 1x and the y-intercept +3. So that's how you can write a system from the graph that you already see. That's it for today. You just have to do the notes. So if you can send me your pictures of the notes on pages 49 and 50. Thank you very much.